Okay, so now it is a problem 5 of our sample 2 of the final exam. Okay, so now it is actually requiring us to evaluate the location of the centroid and moment inertia, radius of gyration of the composite area, right? Okay, so now we can go ahead to approach it. So first, location of the centroid of the area. Well, how can we approach that? So we know that the coordinate of the centroid of the composite area is actually it is a weighted average of the coordinates of the centroid of each part, right? So we first divide the area into regular parts. So it is composed of two rectangles, right? Actually, it's a rectangle 1 and it is a rectangle 2. Okay. So now for the two rectangles here, so we know that the x bar of the composite area equals to summation of the area. Area I is actually the area of the S regular shape times x bar I. X bar I is actually the x coordinate of the centroid of the i's regular shape here, divided by total area. Okay. So now specifically for this problem here, so for area 1, okay. So for area 1 here, and we are supposed to find out the area of the rectangle here. Okay. So actually it is there's a typo here, so the height, and we should know the height we should know the height of the rectangle here. It is actually 4. Okay. So given that the height is 4 here, so we know the area of the rectangle will be 1 times 4, right? Okay, so actually it will be 1 times 4 and times the corresponding coordinate of the centroid of the first area, which is actually at the very middle here, and the x coordinate will be actually 1/2, right? It is actually half of its width, so it is a 1/2. Okay, then the second area is so the area that will be, so the width is 4, 5 minus 1, right? The head is 6, right? Times the coordinate of the centroid of the second part, right? So the coordinate of the centroid of the second part will be, so it is actually at the very middle of the rectangle here. So it will be between 1 and 5, and at the very middle. So it can be evaluated as 1 plus 5 divided by 2. It is the average of the it is the average of the coordinates of edge, right? Okay. So now divided by total area, and you see it equals to, okay. So the numerator here is, it is actually 1 times 4 times 0.5, and 4 times 6 times times actually 3 here, divided by 4 times 1 plus 4 times 6, right? Okay, so it equals to 2.64, right? Okay, please note that the unit here is an inch. Okay, so similarly, we can evaluate y, and y bar equals to weighted average of the y coordinate of the centroid of each part, right? Okay, so my area I will be 1 times 4, right? Again, it is the same, times it is a y coordinate of the first area, which is at the half of the head, right? Which is actually 2. And the second area here is So the area is 4 times 6. It is the same as previous. The location of the y coordinate. So the y coordinate of a centroid is, again, it is a half of the total height, which is actually 3, right? Okay, which is the 3 here. Okay, so divided by the total area. Okay. So you have it equals to, the numerator is 1 times 4 times 2, plus 4 times 6 times 3, divided by the denominator is the total area, which equals to 1 times 4 plus 4 times 6. Okay, so we have a 2.86 inch. So we have the coordinate equals to 2.64 and 2.86 inch here. Okay, so it is the answer for our first problem here. Okay, so now the second problem asks us to determine the moment inertia and the radius of gyration of the composite ship about its centroidal y-axis. Okay, so now we need to use the theorem of the parallel x theorem, right? So the parallel x theorem. So by parallel x theorem, we know that the moment inertia of the entire area equals to the summation of the moment inertia of each part. Well, the summation the moment of inertia of each part equals to the centroidal moment inertia, right? So it equals to the centroidal moment inertia of each part plus the area times the square of the distance. So it is the distance between the centroid of the area to the axis, right? So it is the summation of that. Now for the first area, so for the first rectangle here, the centroidal moment inertia about y equals to. Okay, so now go back to, so we have that information in our appendix. So now we see here about the y or the vertical direction. So it equals to 1 over 12, right? Times b to the power 3 times h, right? Times b to the power 3 times h. Okay. So it will equals to 1 over 12 times b. So b is actually, so now please note, b is actually 1, right? It is the length of the side that perpendicular to y-axis to the power 3 times h, which is actually 4. Okay, then area 1 times 4. Distance between the centroid to the y-axis, it is actually the difference of the coordinate of the area 1, which is actually 1, which is actually 1 over 2 minus the location of my y-axis, right? So it is actually the x bar here. Good. And you square that. So okay, so to illustrate that, it is actually the distance. So this is actually the distance between the centroid of the first area to my y prime here. Okay, so now it is we can move on to the second part. So the second part, it is again, it is a rectangle. So completely the same formula can be used here. It is a 1 over 12 times b to the power 3. So b here is actually 4, right? So it is 5 minus 1 here times h, which is actually 6. Okay, plus the area, it is 4 times 6 times. Okay, so now it is a distance between the centroid of the second area to the y prime here. It is actually again, so it is a difference between the coordinate of the centroid of the second area 3 and the coordinate and the y coordinate of the centroid or the location of y prime. It is a 2.64. Okay, so illustrate it is actually this distance here. So always, so for I about y-axis, so the distance here is along x direction. So for I about x axis, so the distance here is about the y direction. Okay. So now you can go ahead to calculate that. So for the moment inertia of the first part, it is actually, so we have the all the terms here. We can go ahead to calculate that. It actually equals to, for the first part, it is 18.65. Okay. So for the second part, which is 1/12 times 4 to the power 3 times 6 plus 4 times 6 times the square of the distance. So this distance is not significant. Okay, so now we see that although the area of the first part is significantly smaller, since that has a significant distance from this centroid area, so it still contributes a lot to the moment inertia here. So you take the summation of that, it equals to 53.76 here. It is an inch to the power of 4 here. Okay, so now radius the duration is actually square root of I divided by area. So for I we already have it here. And area, it is summation of the two rectangles, right? So square of that you have it equals to divided by the summation of the two parts. You have it equals to 1.39 inch. Okay, so this is actually the answer for the second part. Okay, so this is our problem 5 here. So again, the problem 5 is examining the evaluation of the centroid moment inertia, radius duration of the composite area. So for the centroid here, it is actually the weighted average of the coordinate centroid of each part. Okay, and for the moment inertia, so it's the core for the second part. It is so to calculate that, we have to use the parallel x theorem to find the moment inertia of each part, then take the summation of that. And after we have the moment inertia, so to calculate the radius duration, it is a more straightforward here. Okay.